All right, everyone. Welcome aboard. Oh, let me let Suleiman in. So, welcome back. Today we are starting basic electricity. So that's going to be, it's tough. It's probably one of the hardest things we do, and it's cool because it's your introduction to how electricity works. So, very cool stuff. I do gotta say, so I went over into the computer lab today, which if you didn't know, that's where our robotics lab is also. And so I was looking through all the stuff today. Man, we got a lot of good labs for this class. I cannot wait. And the funny thing is, your class is weird because since we did distance in the beginning, as soon as we get back, we'll get a launch right into all the labs. So it'll be kind of cool because you're getting a lot of the tedious stuff out of the way now, and then bang, as soon as we're back, you just get a launch into lab, the lab, the lab, the lab, which is really exciting. So that'll be very cool. I forgot how many good labs there are for that class, and when I'm kind of stuck in this distance learning, and I don't like it. I like being in person, and so I just walked over and saw all the stuff. I'm like, oh man, we got so much good stuff to do in this class. So cannot wait. Let me let Alan in here. So yeah, we really do have tons of good labs in here. We got like the soldering lab, the electricity lab, the electronics. We got all the programming. We got the robots. We got all the LEDs. Just tons and tons of cool stuff. So, the multimeter stuff and just really good stuff. Resistor lab and just tons and tons of stuff. So, kind of got me excited when I saw that stuff today. I hadn't been in there in forever since I'm stuck at the computer all day. Okay, so let me try to find my notes for this stuff here. I will share my screen with you. Now, we are going to make a whole new Google Docs for these notes, okay? So go ahead and start a brand new Google Docs, and it's going to be called Basic Electricity, okay? Basic Electricity. So make a whole new Google Docs, title it Basic Electricity. If you need help with that, let me know, and I'll help you get that started. Okay. Okay, so we will not be doing this today. We'll probably do that on Friday, I think. Okay, let me go to the lecture, basic electricity lecture. There it is. Okay, and I want to pull up the. All right, I guess I'll just open this one for now. I actually have a Google Docs of this, and just like before, I'll release it at the end of our notes because I want you to take notes because I want you to practice getting good at them. It's like I told you before, it's a definite skill being good at notes. Like my wife is excellent at notes. I'm terrible at notes. And when we go to study, her notes are so much better than mine. They're so helpful. Mine are not nearly as effective. However, you always have to know that there's a trade-off with everything. And so if you take really good notes, sometimes you have a harder time paying attention to the lecture. And I noticed that with my wife. Like when we listen to something, I get the gist of it, I get the bigger significance of it, I get the hold on, let me let Jameson in. I'll catch all the main points of it that the teacher is talking about because I tend to pay attention to the teacher more, and she's focused on the notes. So at the end, what happens is I don't have very good notes, so it's hard to jog my memory when I go to study, but I know the main points. With my wife, she has all the main points down, but sometimes she misses the big picture of it. And so it's good if you can combine all of this stuff. So what all of us are trying to do is we're trying to be quick with notes so that we can get down what the person's talking about very fast, and we can pay attention to what they're saying. So that's a tough skill, and it takes a lifetime to learn. It's very hard to perfect. And I'll just tell you, I still am not very good at notes, and unfortunately, I didn't start learning them until college, whereas a lot of you guys are getting it early on. I never was taught notes, so that's one of the reasons why I try to specifically go through them with you. No, I would like this to be a docs, please. Google Docs. The title is going to be Basic Electricity, okay? Basic Electricity. Now, oh, let me high in. Okay. So I'm just going to forewarn everyone. This is a massive, massive lecture, okay? It is also the same lecture I would give in college classes. So it's not super easy either, okay? So it's massive. It's way bigger than anything you guys have seen in any of your classes. And it's hard. So I just wanted to warn you of that. Now I'm going to try to make it simple, but you can only make electricity so simple, okay? So this is a huge lecture. We're not going to do it all in a row because you guys would just keel over and die. Okay, it's long, but it will take several sessions for us to get through the whole thing, and then we'll break it up so that we're not just doing notes. Okay, it is interesting, but at the same time, it's very dense. Okay, so we'll try to keep it as strict to the most important things as possible. Okay, so everyone should have your Google Docs out, and it should be called Basic Electrical. Okay. You can call it basic electrical theory if you want, that's fine too. But basic electricity or basic electrical theory, something like that is fine. I don't know. I wouldn't say electricity is the most complicated infrastructure. I would probably say that data networks are the stuff that does your internet and servers, just because they interconnect so much more. So if I had to guess, I would say that. But yeah, it's hard to say. I don't know, because water, yeah, minus probably the data network. I would agree with that, Michael. He said, is electricity the most complex infrastructure for humans? Yeah, I think I would say the data networks. The electricity is probably, it's a little more simple because it doesn't have to it just is such a more simple thing than data going every which way and in packets. Okay, because electricity, all we have to do is figure out where it flows to. We don't have to control like packets of information to. Okay, so do not write anything until I tell you. Okay, we're gonna keep the notes very simple. You know me, I do not like tons of notes in class. I like class to be hands-on learning. So I will try to keep this as simple as possible, okay? I like that. They have to bend light or stuff. Yeah, fiber optics are going to be using light waves to communicate. Very cool stuff. We'll do a little bit of that at the end of the year. I think we'll still have time. Okay, so basic electricity. What is electricity? So it's invisible. It can hurt you. We can control it, and we can predict it. Okay, so these are four of the most important concepts with electricity. We can't really see it. You know, you could see lightning bolts, you could see static shock sometimes, but most of the time you can't see electricity, but it still can hurt you. So it has to be controlled and protected so that you can't get hurt by it. Yes, I can always grade as long as there's time after class. I can always grade stuff. I'll try to end a little early so I could do that. Let's see here. So we can predict it, and we have to predict it using math. So that's kind of one of the cool things of math, is that it will actually give us the answers to this electricity stuff. Okay, so here is one thing I want you to write in your notes. You're going to put current flow theories, okay? Current flow theories. That's the first thing you want to put, and you want to put 2 bullet points under it. We're going to have electron theory, and we're going to have conventional theory. Okay, so I'll give you a minute or two to do that. Okay, so current flow theories, and there's going to be 2 of them, electron theory and conventional theory. I'll give you a minute to write that, and then I'll tell you what they are. Very good, Samara, I love that. I can't tell you how much I love hearing you guys do nerd jokes. Did you guys read that? Fiber optic cables are healthy. They have a lot of fiber in them. I was just about to yell at you to pay attention and get your notes done, and then I saw that. Okay, so current flow theories, there's two of them, electron theory, conventional theory. All right, so make sure next to your electron theory and conventional theory, you put that minus to plus and plus to minus, okay? So electron theory, put that minus to plus, and conventional theory, put that plus to minus. Do not mix them up, because that's the whole point of the theories, okay? So I want you to put those in your notes right there. That'll help remind you. Okay, everyone got that? Good to go on. You got to kind of chime in a little because I don't know how long it takes you to do it on the computer. I can't tell. Okay, we're good to go. You've got the minus to plus and plus to minus on those. Okay. Now, Suleiman's very close onto that right there. That's a good way of thinking about it. So the way I want you to think about it is this, okay? Now, when we think of pressure, we always think of things flowing from high pressure to low pressure. And that's the case with water. That's the case with air pressure. When you talk about the winds on the planet, that's air moving from areas of high pressure to areas of low pressure, okay? When you talk about water flowing, water is going to flow from areas of high pressure to low pressure. If we try to compress water, it doesn't compress and it's going to flow out somewhere, okay? Like when a pump's pushing water, it's trying to compress it, but it doesn't compress, so it just moves, okay? And so it's going to go from high pressure to low pressure. And we use that all the time. So that makes a lot of sense. So when we first started to talk about electricity, back 150 years ago, 180 years ago, when they first started to talk about electricity, they thought that made sense for electricity too. And it does. It seems like it makes sense. It's going to flow from high pressure to low pressure. Okay? Now, that's the conventional theory. And conventional just means it's been around. It's the conventional thinking. It's like typical thinking for a long time. Okay? Now, electricity's been around a long time. They even think ancient Egyptians used electricity to plate things in gold. So it's been around a long, long time. And the funny thing is they used olives and citrus type fruits for batteries to be able to do it. It's really kind of cool stuff. Okay. Hold on, what am I seeing here? All right, I'm turning chat off for a minute. So I want you guys paying attention. So conventional theory is what we thought of electricity for the longest time. And that's saying that electrons are going to flow from positive to negative, okay? That's the one that makes sense. We still use conventional theory all the time, okay? That's what we're going to use in this class. We're going to use conventional theory. Anyone that works with electricity thinks in conventional theory. So like electricians, people, electrical engineers, we all think of it like that, okay? From positive to negative. It makes sense. All of the drawings have been drawn that way for the longest time in the, since electricity started. They've all been drawn that way. So conventional theory is the way we've done it forever, and that's the way we're going to continue to do it. However, I believe it was in the 80s, but physicists figured out that that's actually wrong. And what they figured out is that electrons actually flow from negative to positive, okay? So that's called electron theory. And in truth, that's what happens. Electrons flow from the negative side to the positive side. So they flow backwards of what we were thinking, okay? They flow backwards of the way we were thinking. I wish I had a little wiring diagram here, but I have it later on. We'll talk about it then, okay? So just wanna throw that out there. So the truth of the matter is that electron theory is the real way that electrons move. However, we all think of it in conventional theory. So when we talk about our wiring diagrams and all of those patterns that we're going to do a little bit later, we're going to think of electricity flowing from positive to negative, okay? Now, in reality, it doesn't matter, okay? We don't care. As an electrician, we don't care if the electricity is going from the positive to the negative or the negative to the positive. It does not matter to us. We're just going to wire everything up. It's going to work, and we don't really care about the science of it. It's not an important thing. But as an electrician, as an electronics student, you got to understand the difference between these, okay? Some of you are going to probably go on to be electrical engineers or computer engineers, and you'll need to know this because that's where it's really important. But at that level, it matters. And same thing with physics. If you study physics, it matters to them. Okay, but on a practical side, for us using electricity, we don't care. It doesn't really matter which way it flows to us. Okay, so we're going to always use conventional theory, even though electron theory is the correct one. Okay, when we get into some of the symbols and electronic components later on, you'll see why it's important which way the electricity flows. But once whoever's designing it designs it, we don't care anymore. It doesn't matter. It just works. We'll put it in. We know how to use it. Okay. Let's see here. Suleiman, are you telling me Egyptians didn't use electricity?
Yes, the vases just coincidentally used were in the shape, sort of the shape of a battery. It's highly likely that they actually were batteries.
Well, I'll tell you, I'm a history major, and one of the things that we found out was that ancient Egyptians used olive oil to plate metal with gold, like a really thin layer of gold plating.
Okay.
So they used very simple batteries. Like we could use an orange to do it, but they used olives. So anything kind of acidic like that can work as a battery. And so they used it to plate gold. Now they didn't know what electricity was, but they were using it nonetheless. Okay, let's see here. What about a potato? Very good. You could use a potato as well. That's one of the things I always wanted to do in class. I just have never gotten to that, but it is fun. You'll see potato clocks out there. They're very cool. Let me see how much time we got here, because I know these classes go by quick. 37. Okay, let's just do this next slide, and then we'll call it for the day. The only thing I want you to write here, no, don't write any of this. Don't write any of this. We'll just talk about it. Okay, so matter. Okay, matter is anything that takes up space and has mass. So anything you can touch, your table, your pencil, air molecules, dust, dirt, your hair, electrical, insulation, all of those things have matter, okay? Matter can be solid, liquid, or a gas, and it's made up of different combination of atoms, okay? And this is one of the areas where things have been changing really rapidly. Like we used to think atoms were the smallest particle, and then we thought quarks were the smallest particle, and they keep finding smaller and smaller particles. But for right now, we're just gonna say matter is made up of atoms, and that's what we're gonna work on in this class, okay? So we know that matter could be solid, liquid, or gas, and then we're gonna look up what matter is made up of, because that's gonna lead us into electrons, okay? No, you do not write this, don't write this. Again, I'm trying to keep this simpler for you guys. Like I said, this was the same lecture for my college classes, and I just go into a lot less detail with you guys because you just haven't gotten to some of this stuff in science yet. It's okay. Let's see here. Okay, I'm gonna call it there for today and let anyone who needs to get stuff graded be graded. So if you don't need anything graded, you're free to take off. If you'd like to stick around and get something graded, stay put and I'll help you do that, okay?